Hi, this is Janos, this is Real World Audio, and finally I'm back here online on YouTube. In the past 2 weeks I haven't made any videos, had lots of things happening in my life and not enough sleep, so I've been pretty much sleep deprived lately, and that's the reason why I haven't given any advice on projects for the past 2 weeks really. Because when I don't feel in having my full faculties, then I don't want to give any serious advice on decisions about any projects, because I don't want to, when I cannot give you, and I cannot see the whole picture because I'm too tired to look at the whole picture, then I know that whatever information I will provide to you will be useless and will put you to chase proverbial geese. However, now let's have a look at something absolutely amazing. And what you are looking now, first of all, behind me you see these are my LaGrande speakers, and what you see in front of you on the big screen, these are Adrian's LaGrande speakers that he built. And these ones, he had a pair of Fostex FE126E drivers, which are a little bit quite different from the ones that I use here. So Adrian resized his cabinets quite a bit to accommodate these drivers, and we found different dimensions to make these drivers work with the LaGrande design, and these ended up 60-liter cabinets, which is quite a big, like 50% bigger volume than my LaGrandes. And he said that he absolutely loves them, and there is a video. This is Adrian's channel, and he provided this video. Look at that, and he is showing the insides and the construction, and it's a really short video, and it's fantastic. He shows absolute beautiful work with it, and I really recommend for all of you who are interested in this design to just have a look at it. And also as a feedback, that if you have a different driver, it can be made to work in LaGrande, and it can be modified and adjusted. Also, if you do not modify the design, it will still work. It will not be optimal. You can get a lot more out of it, and as Adrian did, by adjusting the cabinet size and adjusting the port height, etc. And also he was asking about driver updates, because he was so impressed with it. He's thinking, okay, how can I improve on it? And one way, he's really interested in the Sonido drivers, and actually I think I'm not exactly sure where I left off with my advices, but what I recommend is to get the SWR 200As, so not the SFR but the SWR series. And actually the manufacturer of Sonido himself, he also recommended to go with those drivers, and my recommendation after looking at the frequency response and those drivers is also to use that and not the SFR series for this cabinet specifically. You'll be, I think the best fit will be that driver. I haven't made any of the calculations for the width of the cabinet, but I think from what I did and based on my level of sleep deprivation, I can say that it will be a safe bet that driver will be a really huge upgrade from the 126E and will work in this cabinet. So I think this was the most important bit that I wanted to share today, and congratulations, Adrian, for your amazing project, and I really hope that these 4 likes will be 40 by tomorrow, and these 4, there will be a 0 added to these 40 views here. I will also put a link to the video, so you will see it appear at the top corner at the end of this video, link directly to this video. So you just have to do one click on it and you don't even have to search for the link. Thank you, Adrian, for sharing it with us. And now for the second part, I would like to answer one of the questions I received. So now you see I'm getting like really like quite a bit of delay and lag in answering questions. And this is from Benjamin Lloyd, and he says, I'd like to learn more about transformers in crossovers. I heard they are better for high frequency crossovers, especially with silver. And so for that, to answer this question, first I will specify where you can use a transformer in the crossover and when to use, because you cannot just put a transformer into any crossover, because the primary role of transformers is impedance matching, and when you have a tube amplifier, your output transformer does the impedance matching to your loudspeaker. Now, in a fairy fantasy world, everything is perfect and your loudspeakers are perfectly matched to your amplifier. In the real world, if you have a solid state amplifier, then it's almost never perfectly matched to your loudspeaker. And I know the solid state camp will come and type as one that, yeah, no, it doesn't matter. And I only think that matters with the solid state amp that it has the damping factor up the wazoo, and it can dump unlimited current onto the speaker, and that's all you need. And my answer to that is no. Yes, that is practical, that is handy, and when you have that kind of approach, you can drive difficult loads, but it just means that you can drive. It's kind of like having a tractor, and you can just, you know, pull like tons of junk behind you, and it doesn't matter for your tractor whether you are pulling like 10 pounds or 10,000 pounds. The tractor will go at the same speed, you will take the turn same way, nothing will change regardless of the junk behind you. But that's not really what quality audio is about. Quality audio is that getting the best match out of your speakers and amplifiers, and that aspect, that when we just think that we can dump as much current on the speaker as we can, it just means that you have a wider range of loudspeakers that you can attach to that loudspeaker, and it will make sounds without gross distortion at very high sound pressure levels. That's all that it does. However, when you have any specific solid state amp and any specific loudspeaker, to get the best out of this specific combination, out of the unit you have in your home, the amp you have in your home and the speaker you have in your home, is when the impedance of the output impedance of the amplifier and the input impedance of the loudspeaker, they're properly matched. And they are not, because there are no impedance matching between a loudspeaker and a solid state amp. They are just using feedback just to get rid of this problem, but all that it does is gives you the ability to dump current into a loudspeaker, but it does not give you the ability to match it perfectly. There are some companies who have impedance matching for their amplifiers, and one such company is Macintosh. So they use output transformers, sometimes not a transformer, just an autoformer, which means it has only one winding, that's a secondary question, but they use an impedance matching device. And of course I will get a million comments that Macintosh is not end of the world, and those comments will get additional comments from Macintosh fans who say that yes, I have Macintosh amp and it's the best amp I ever heard. So all of those things put together, what I can tell you is that Macintosh do voice their amplifiers to a certain specific taste, and within that specific taste, the ability that you can attach your speakers to an 8 ohm tap or a 4 ohm tap or a 16 ohm tap makes a difference to get the most out of your loudspeaker and amplifier combination. And when you have these different impedance speakers, you will be able to match them better to your Macintosh than you can match those different speakers to an amplifier that doesn't have impedance matching. When you have an amplifier that doesn't have a built-in like different taps for different impedance loudspeakers, there you will find an impedance range that works best for that amplifier, and it will not sound good with other impedances. So that's one point where transformers can be used. However, and I only mentioned this because the transformers came up with regards to loudspeakers. However, this very specific question asked about transformers in the high frequency compartment for the loudspeakers. So what is that? So that is something really specific, and it's required when you have a loudspeaker that has a tweeter in it or a compression driver. And when you have let's now take just a very, very simple example. And the simple example is to have a two-way loudspeaker with a tweeter and a woofer. And for the woofer, you have a low-pass crossover. And it means that we are cutting off the high frequencies. So the easiest thing to do that is to add the choke, which is a coil, basically almost like a part of a transformer, one side like a primary coil of a transformer without a secondary, and that acts as an inductance. So basically we have an inductor, a half of a transformer, and that inductance, it smears the high frequencies, so high frequencies will not reach the woofer. And based on the inductance reacts with the impedance of the woofer at each of the frequencies, and at each of those frequencies there will be different amount of attenuation in the signal. And for the tweeter, we have a similar thing going, but there we add the capacitor in series with the tweeter for the crossover. And now this is the most basic. So when we add just an inductor and just a capacitor, this is a first order crossover. And now I'm just staying at the first order crossover to keep it really, really simple. And when you add that capacitor in series with the tweeter, what it will do, it is a capacitor blocks DC, blocks basically 0 Hertz. And the smaller your capacitor is, it blocks not just the 0 Hertz, but it blocks the low frequencies as well. So in other words, the bigger capacitor you have, the bigger the capacitance it is, the lower frequencies it will let through. But for tweeters, we use it to block the low frequencies, because those tiny tweeters, they cannot handle the big, long, low frequency signals. That's what the woofer is for. And in a perfect world, this is all you need for a simple two-way loudspeaker with first order crossover. Just a capacitor for the tweeter and an inductor for the woofer. So where does the transformer come in? Basically, when we need to make this situation more complex is when there is a difference between the sensitivity of the tweeter and the sensitivity of the woofer. And always it is really hard to make a very sensitive woofer, and it's much easier to make a sensitive tweeter. And in the majority of the loudspeakers, the problem is that the tweeter is more sensitive, more efficient than the woofer. And to compensate for this efficiency, which is like 1 dB too hot, or 2 or 6 dB, or often 10 dB, 15 dB, we put in a compression driver, it might be like 20 dB too hot compared to the woofer. So then you need something to cut the level of the tweeter. So you need to cut not only the bass frequencies, the low frequencies, but you also need to cut the level, average level of where the tweeter operates compared to the woofer, to bring them close together. And in loudspeakers where this is not taken care of, those loudspeakers, then the high frequencies are really harsh and brittle, and they bake and cook your ears. And I don't want to mention such loudspeakers now, but there's plenty commercial speakers where they have the tweeters like 10 dB hotter than the woofer, or even hotter than that. And you can pay money to obtain it and listen in your own room for your own convenience or inconvenience. However, that will, and why do manufacturers do that? Are they not aware that, you know, like at 10 kilohertz, like between 2 kilohertz and 20 kilohertz, it is like 15 dB hotter than the mid-range, lower mid-range and the bass? Probably they are aware. They must do at least some frequency measurements before they sell the speakers commercially, but they think of it as a feature. And also when you have that kind of thing, because the high frequencies are popped up, it will create the illusion of having more extensive imaging. So when you hear that, the high frequencies, like if you have any kind of ding, any kind of sharp notes and sounds, the 3D image will be hyper realistic. It will be ultra real. However, what will happen is that after like half an hour, you will have such extreme fatigue that you will take the product and personally do a throwing contest, like how far you can throw it after you came out from the ER with a bill to treat your ear problem that you got from the speaker. So to prevent that kind of scenario, those manufacturers who are not for those cheap thrills to impress the unsuspecting, unknowledgeable customer with cheap tricks, they level the tweeter properly because they want to sell a product that you can listen to for years and years and years, in contrast to a product that you listen to for 5 minutes in a showroom, and yes, it has much better imaging, much sharper everything, because the highs which carry the imaging details are present at much higher level than the rest of the spectrum. But it won't work on the long run because it will totally burn and ruin your hearing. So to level the highs, we need a resistor to drop the levels. Now what happens when you put in a resistor? A resistor, what it does, it burns up voltage, it burns up current. So basically it transforms the information that is sent from your amplifier, it transforms it to heat. It is lost. It will cause losses. And this is how I call it differently from most people. Most people say that it's just limits the voltage or divides, voltage divider, kind of. But it's not just doing that. It is getting rid of part of the information that's coming from your amplifier. And when you do that, when you start like putting in resistance in your signal to cut the tweeter level, you will notice that it's not just adjusting the level, but something is being lost in translation. And the bigger the resistor you put in, the more is lost. And if you want to experiment with that, try with the bi-amping setup. So you have different amplifier for the woofer, different amplifier for the tweeter, and try a scenario when you have the same volume from both amplifiers going to tweeter and woofer, and cut the level with the resistor. And the second scenario, when you adjust the level of the output from the amp going to the tweeter and there's no resistor there. And then you will notice that the second case, you will have much cleaner detail and it will be much more livelier sound. And when you have the resistor leveling the sound, then it will sound progressively more dull and flat as you increase the value of the resistor. So, in summary, there are two lessons to be learned from this. Lesson number one is that the bigger the resistor you put in there, the bigger the loss of life, and the bigger the intrusion will be to the integrity of the signal coming from your amplifier. So, if you have a loudspeaker where you have maybe like a 1 ohm resistor or a 2 ohm resistor, something really small, adjusting the level of the tweeter, I would say do not worry yet about switching that to a transformer. The gains will be probably not even audible. What you should just worry about is to get a high quality resistor in that spot. That will provide a nice upgrade. However, when you have a high value resistor and the value of the resistor is equal or greater than the impedance, the nominal impedance of your tweeter, that's the time when it's time for a transformer to match the volume level between the tweeter and your amplifier. Then you will be massively audible when you use a transformer instead of a resistor. So that's one thing. However, there's another consideration as well, and I think I'm going to go into it in the next video, is that if you put in, let's say you had an 8 ohm impedance driver with an 8 ohm resistor making the dB cut, the SPL cut to level it to your woofer, and now you change it to a 1 to 2 step down transformer to match the same cut, the output you are getting will be different. So it will not be exact same. So when you change resistor matching, SPL matching to a transformer matching, they will not be the same, and you will most likely need to fine-tune your crossover. If it's the first order, then it will be very easy, because you just need to probably just adjust the value of the capacitance, fine-tune it to the transformer versus the resistor. But if it was a more complex, then you might be up for a little bit of more trial and error, just experimentation, which is fun and great. We will go into that at a different time. One thing now that I want to finish off with is Benjamin mentioned silver for the material of the transformer, and yes, I can confirm that. And why you want to do that is because silver is sensitive to much lower levels, much lower signal levels than copper. So that's why silver wound transformers. So a silver transformer is the winding, the wire in it is silver, not the metal core of the transformer. It's not. But the primaries and secondaries they are the ones which are fond of silver, which makes it extremely expensive, and not because silver is such an expensive material, but because you cannot just put in a piece of silver wire that you can buy at a decent price, but it has to be enameled silver. And God bless you if you want to find the appropriate gauge enamel silver at any price. Well, it will be at this price, and which will be reflected at the transformers you buy. And so that's why it's going to be expensive, because the wire, your silver, has to go through that specific process to make it suitable for transformer use. And that's why we are paying that extreme premium to use the silver wire. However, because silver one transformers are just annoyingly expensive, and unless you want to double mortgage your home or cancel your health insurance or donate a kidney in the black market, then most of us, what I recommend for all of my listeners, all of you, everyone, is do not go for all kinds of advices on random videos that you find that, here's this special silver transformer, you need to have that, and then you forget everything, and then you are looking it up, where can you find it 5% cheaper to buy those transformers. No, what I recommend is to keep your eyes open, learn about audio, learn what transformers do, what drivers do, what cables do, what your power cords do, what your speaker placement do, and be informed of them. And when you find opportunities that come to you, which are accessible to you, you notice on Craigslist that someone is selling such and such a transformer, buy it. You see that somewhere like, Altec 515B drivers come up for $20 a pair. At the same second, you type for that guy and say, I'll be there in 1 hour, and pick them up. And just be knowledgeable enough what to look out for, and when it comes up, then grab it. And for every single one of you, I guarantee, flat out guarantee, that you have come through hundreds of, maybe not hundreds, but at least dozens of outrageous deals that would have just radically transformed your audio system at a cost that you can absolutely afford. But you need to keep your eyes open, and when the opportunity comes, grab it. And then you will be able to really put together a phenomenal system. And under phenomenal, I mean that if you want to improve on it, and improve on it on a level that you just want to make like a 5%, like a minuscule difference, such a difference that even you have to do critical listening, like sit in a critical listening mode to tell the difference between yes or no. And if you do that mode and you have people in your home, they won't even notice that anything is changed. But even for you, it will be like a critical listening type of difference. And even that will cost you like an arm and a leg to reach that kind of tiny thing. But keeping an open eye will just get you like there. And if you want a tiny bit more, yeah, you can mortgage your home, but do not go out of your ways in search for a silver transformer for your crossover, because that will not make or break the system. In my system, for the voice of Lancelot, I have Macintosh autoformers. So what I use for impedance matching, those are the output transformers of Macintosh solid-state amps. And that's why I was talking also solid-state amps in the beginning, because Macintosh did outrageously high-quality autoformers for his solid-state amps, and they are absolutely perfect for impedance matching for crossovers. and to beat that transformer's quality, it would be, yeah, I would need to mortgage my kidney or something like that for a silver transformer, and the difference will be such that probably people won't even notice it. I would notice it if I go into a critical listening mode. And the current transformers that I had, I scavenged it from a broken Macintosh amp, which was rusty, and it was beyond salvation. It was going into the dump, and I found, look, someone tossed out a pair of Macs. So I went in and, you know, just removed the autoformers from them, and yeah, that's what I use. So and that's what you can do for yourself. Keep your eyes out open for like Craigslist ads, and you see someone has like, broken Macintosh amplifier, and if you know that, this one has that autoformer, has an autoformer for the output, yeah, grab them. Even if they don't work, take out the autoformers and use them for crossovers, and they will be extremely high quality units. So I think this is for today, and I hope this little info was useful, and I want to make a follow-up on this, showing what is the main difference between using a transformer and resistor for the leveling of your tweeter or compression driver, and what is the fundamental difference between the two, in addition to what I told just now, the level of detail and liveliness. So just think about it this way. When you have a resistor, it's like pushing the brake pedal. Look, I'm giving you a car analogy. So in the car analogy, the resistor is the brake pedal. So you are braking the car. And when you are braking the car and you try to accelerate and decelerate, accelerate, decelerate, accelerate, decelerate, and if you're constantly braking, even if you want to accelerate, the car just won't accelerate as much. And the transformer is like a transmission. So like you shift gears and you are not pressing any brakes. And when you slam on the accelerator, the gear shift, the gearbox will provide you additional torque. So instead of just having a foot constantly on the brake pedal and it's holding you back, instead you have additional torque to drive those loudspeakers. That's why they sound more lively, and they are able to transmit more information compared to choking them down with a resistor. However, okay, I'm not saying anymore. You will find it in the next episode, some application notes on transformers versus resistors on crossover networks. So thank you for being here, and thank you, Adrian, for sharing your loudspeaker build, and thank you, Benjamin, for your question. Bye bye.